To continue into chapter 14 and look at surface area. Surface area of a right prism is going to refer to the sum of the lateral surfaces, meaning every side, and the area of the bases. This is often a place where we start teaching formulas before we teach the conceptual understanding. So make sure that you start with conceptual understanding first, then you move into the formulas. So here are the formulas for the surface area of a cube, not a square. Watch terminology in your students as well. A right pentagonal prism, this is the formula for that. And this would be, if I want to find the surface area of the prism, I haven't given you a formula for this yet, but we know that I could find the area of my base, which is 1/2 the base times the height, so 1/2 of 3 times 4. Then I can find the lateral perimeter, and I get my surface area would be, I have two bases with that area plus my P times my height, which is going to give me 132 centimeters squared. Notice the units for surface area match the units for area. Here are some additional surface area formulas to aid you as you move forward in the course. And if we're looking at a pyramid, there are different types of pyramids, which is something that might have been glossed over in your previous math training. So a right rectangular pyramid is a unique type of pyramid. If I want to find the surface area of this pyramid, I'm going to take that process from the previous slide. I'm going to find the area of my base, which is going to be a square, so side times side. And then I'm going to find my p-value and do the surface area formula. Here's another example, but in a word problem format, which makes things interesting. So here, I know that one side of my square base is going to be 235. So if I find that, the lateral surface area is going to be my four sides, and that's going to give me my total surface area of the Great Pyramid. Here's, if I'm looking at a Trans-American building, then I'm going to look at, here's my lateral surface based on what I had for my side. And I'm looking at comparing that to the lateral surface of the Great Pyramid. And if I look at it, I look and see that it's about 4.95 times as great as that of the Transamerica building. That's pretty much a huge scale factor. The surface area of a cone is probably one of the easier to remember formulas. So we're able to actually work with it, but we do use what we call slant height for this, and that's the L value, which happens to be the hypotenuse of that right triangle, and not the actual internal height. So in this example, I'm looking at the cone, and notice that 5. That 5 would be that slant height we were talking about. And I plug in and I get 24 pi centimeters squared. Make sure you specify with your students if you want them to use 3.14 for pi or if you want them to use the actual value pi. If I want to find the surface area of a sphere, I'm going to have to use that plane as if I cut an orange in half and I use that great circle. So when we cut the orange in half, that circle on either side is considered a great circle. And I'm able to then apply the surface area formula to find the surface area of that great circle.